Beautiful. Good. All right. Beautiful. So now what we get to do is, well, oh, sorry. Now I want to show you another way. Remember how I said you can solve a system like this using more than, by eliminate in different ways, even using elimination, right? So in the previous one, we eliminated y. We could have eliminated x, though. For instance, here's what I can do. I could take the first equation, right, and multiply it by 3, as you can see, right? And we'll get 6x plus 9y is 63. In the second equation, we'll have -2. We can multiply it by -2. We'll get, and then distribute, we'll get -6x plus 8y equals -46. Now, then the system becomes this. Now, why did I do that? Well, you can see that if we add, the x's are going to go away. The x's are going to go away. Okay, so what do? We add them. As I said, the x's are gone. 9y plus 8y is 17y. This equals 63 minus 46, which is 17. Okay, that's what we get here. So again, we added, we get 17y is 17. Of course, that implies dividing both sides. Dividing by 17, you get 7. You divide both sides by 17, right? You get y equals 1. Now, once we know y is 1, we can get x because we use one of these two original equations. So you let y be 1. What does x become? Well, let's see. We have 2x plus 3 times 1 equals 21. 2x plus 3 is 21. So what do we do next? Well, from here, we want to solve for x. So we subtract 3 from both sides, right? We get 2x equals 18. Almost there. We divide by 2 because we don't want 2x. We want x. So x equals 18 over 2, which is 9. So we get the same answer, which is what should have happened, 9, 1. So we have that. Are there questions about this? Okay, so here's another example. Let's do that. So this is, we're going to solve this also by elimination. Now, notice that for the first equation, we have 4x, we have minus 8x, right? So if we multiply the first equation by 2 and add, the x will go away. So let's do that. So I'm going to multiply the first equation by 2, both sides that is, right? We have 2 times 4x, that's 8x. 2 times 7y is 14y. 2 times -3 is -6, as you can see. Okay. So now, by doing that, the new system we get is this. And yes, you can probably see what's going to happen, mostly because it's down here. If we add these two equations together, right? 8x plus -8x, that's a 0. We have 14y minus 14y. That's gone. -6 plus 6 is 0. So in this case, we have 0 equals 0. We have an equation that's true no matter what the variables are. So that's great. We have infinitely many solutions then. Hence, these equations are dependent, which is nice. So there are infinitely many solutions. Okay, let's see. Are there any questions on this? Next one I was going to have everyone try, but low on time, so I'll just do it. Okay, this one originally I was going to have everyone try on their own first, but we have less than 2 minutes, so let me just go through it. So again, there's more than one way to handle this. What I did, I multiplied the first equation by 2, right? Because then you can see that the coefficient of minus y here will become minus 2y. And then you can add the two equations. And what happens when you do that? The y's are going to cancel. So in other words, I multiply both sides of the first equation by 2, okay? We get 10x minus 2y equals 10. That's the first equation. So this is our new system. Now you can see that if we add these together, these y's are gone. 10x plus 3x we get is 13x. The y's are gone. Here we have 52. So we have 13x is 52. How do we get x? Divide both sides by 13. So what do? We divide by 13. We get x equals 4. Okay? So we get x equals 4. Now we know what x is. What do? Just like before, we choose either equation, right? And we replace x by 4 and solve for y. I go through the calculation here. I'll let you do that on your own because we have like 5 seconds left. You get y is 15, and this is the only solution. Okay. So I do have office hours today. If I don't see you there, I'll see you Monday.